All right. Thank you for joining, everyone. So I'm Nate from the Sydney Informatics Hub, and I'm here to tell you all about this low-code, no-code tool for data exploration and analysis and machine learning. So big thanks to Christian who put most of this content together, and I was just lucky enough to get to deliver it as well. So we're going to learn all about this Orange data mining tool. Happy little logo, fantastic, very friendly, and a great user experience. As I mentioned, feel free to interrupt and ask questions if I'm talking about something and you need more detail or going too fast or too slow. You can even pop questions in the chat as well. There might be a few keen people here to answer questions. If not, I'll get to them eventually. All right, still a few people trickling in, but get through all the preamble. So I'm from a place called the Sydney Informatics Hub at the University of Sydney, and we are all about empowering researchers with modern and also traditional data and computational methods. So we want to enable excellence in computational and data-driven research through advanced digital infrastructure, expert data science consultancy, and also analytics training. And that's what we do. So the way we do that is through consultations and projects, sort of one-on-one consultations and projects with either individual research groups, individual researchers, or different parts of faculties and core research facilities. We also provide support around grant applications. So if you need help sort of with methodology, writing time required by us into the grant, and also estimating sort of computational numbers, we can help with that. Our expertise sort of spans data science, machine learning, artificial intelligence, statistics, bioinformatics, more traditional modeling and simulation, and also just general analytics. And all this is supported by the various research compute platforms we have at the university. So you might be familiar with the Research Data Store, RDS, the Artemis High Performance Computer as well, which is being replaced with the Sydney Research Cloud next year. So that'll be an exciting space to watch out for, along with national facilities as well, like PAWSI and the National Computing Infrastructure. Different computing platforms. And we also host a monthly hacky hour, which is a drop-in session where you can bring any research problems or coding problems, and we can always find some expertise to help or guide you to some solution. And we offer training as well, like this. So thanks a lot for coming. Without further ado, we will get into the subject matter. So we're talking about Orange today. So firstly, I'll ask the question, why Orange data mining? So that's the name of the tool we're focusing on. So what we see is that using machine learning requires software development skills generally, and that has a long learning curve. So Orange allows access to machine learning a lot quicker with zero code. So it's fantastic. You don't have to use any code at all. And so even for experienced developers and coders and machine learning experts, using a range of packages and tools can be arduous, and focus sometimes sort of gravitates towards the code rather than the problem you're trying to solve. So Orange prevents you getting caught up in coding and keeps the focus sort of high level, and you can focus on what the research outcomes are supposed to be. And so often only after exploration, you need to make a decision, to make decisions, you let me say that again. Often only exploration is needed to help with your decision making. So as opposed to building sort of large computational pipelines, so you may not know what story your data is telling until after you've looked at it. So that's why Orange is really good for that. It makes exploration much quicker and provides an ecosystem of relevant models and operations meaningfully categorized, as we will see. And so what exactly is Orange? Orange data mining, it's an open source software tool. It's built primarily for data analysis, visualization, and machine learning. And it is built using a Python framework. So it's in a very well-supported programming language under the hood. You don't need to touch that. But if you do then want to extend the things that you use Orange for, you can go into the programming world and use Python to do that. So it provides a really user-friendly drag and drop graphical interface, which we'll spend most of our time on today. And it's definitely not for every scenario. So the best times to use it is when you're doing rapid exploration of data and models, learning and teaching, like today. It's fantastic for that. And if you're not sure where to start as well. And so if you have short time frames, also good for that quick sort of turnaround. So when you want to avoid it is when you have much larger data sets or constantly changing data, or if you need explicit reproducibility. So a computational pipeline that you can just repeat a million times or give to collaborators externally, or have someone download it in Lithuania and run it and get the same results. Orange, you can do it with that, but it's probably much more practical with traditional code. And also, when you're doing advanced modeling, especially things like hyperparameter optimization, which I can talk about if we get to that. Okay, so the main concept around Orange, it's built around these items called widgets. And each widget does a particular task, which could be data transformations, building a model, it could be wrangling the data in some way, it could be a machine learning tool or a statistical model. And so all these widgets represent something, and there's inputs and outputs to the widgets, which are connected to each other via things called channels. So we'll see shortly that we have some widgets represented here. Channels connect together, and we can make a scatter plot from data to table to scatter plot in 3 simple widgets. And a series of widgets and channels builds something called a connected workflow, and changes permeate through the workflow automatically. So yeah, you don't need to sort of hit go or refresh or run again. It just all happens automatically. And there's dozens of widgets available, and you can actually even write your own if you're that way inclined. But they are heavily curated and very high quality. So we'll get to all that shortly. In fact, we're going to jump straight into it now. So basically, we're going to go through some data exploration and learn some machine learning tasks and tools as we go, and see how we can use a model for prediction. Okay, let me reshare my screen. Share. Actually, I'll stay here for a moment. So Orange. Let's go Orange data mining. I'm going to go to this website, and I will copy and paste this in the chat so you can follow along. Yeah, very, very friendly and approachable website, I think. And this big download button is on the front page. So if you want to download it on your own system, it's supported by Windows and Mac. It's predicted that I'm on a Mac here, but you can also download the, oh, am I sharing my screen? No, stop sharing, sorry. Okay. So yes, hopefully I'm sharing now. Please let me know if I'm not. I think, yes, good. So as I was saying, you can download it for Windows or you can download it for Mac. You can even install it on any other platform with a little bit of code there, but you don't need to do that at all. As I mentioned, it's all written in Python under the hood. But basically, you just download the one appropriate for your system, follow the install prompts, and you should be able to launch Orange very quickly. I already have it here, so I'll just open it up. And just opened on a new page. So here is Orange in action. Let me do this, and I will reshare the screen here. So hopefully, if you're following along, you can kind of split the screen in two and go from there. And just noticed a question in the chat. What's considered a big amount of data? Good question. So kind of depends. If it's the bigger you go, the slower things can get. I think traditionally big data is when you can't hold the data set in a normal amount of RAM on a desktop computer. There's lots of ways around that, but I think big data in this instance could be, I'll give you a number, let's say 10,000 rows, maybe 100,000 rows of data with about 100 columns. Anything bigger than that, and it'll probably struggle on even on a modern computer. We'll see. All right. So yeah, this is Orange. When it boots up, it looks something like this. On the left-hand side, we have a bunch of widgets here, and we can pick sort of what we want to start with. So I'll talk through quite a few of these as we go today. And the very first one I'm going to click on is File. So if I just click it once, this File widget appears in my workspace over here. And believe it or not, that is how we get data from our computer, from our local machine. And if I double click it, it opens up a window that looks like this. So by default, it's actually loaded in the data set that I want to use today. This is one of the demo data sets that comes with Orange. So I'll explain this in a second. But if you were looking for any data set, you'd basically click this button here, and then you can navigate through your computer to find where you keep your data. In this case, it's buried in the Orange installation. So on Mac, it's in the applications folder. In Windows, it would likely be in C drive program files if you followed the default place. And if you are familiar with Python, you might recognize sort of this absurd file structure. So it's buried very deep, but that doesn't matter. We're going to be using this data set that comes with Orange called heart_disease. I'll click open, but I'll also just go and just open this in the Finder window. So this is the same folder, just so we can see what this looks like. There's nothing special about this file. A .tab file means it's tabular, so it's very similar to a CSV file, except tab separated. You can open it in a text document. It looks something like this. It's just plain text, or I can open it up in Microsoft Excel as well. Let's do that. Yeah, don't need to do this, but I'm just showing it for demonstration purposes. So yeah, nothing too exciting about this file. So at the top we have our the column names. So this is a data set related to heart disease and physiological factors around what might be relevant to predicting if a patient has heart disease or not. So things like their age, their gender, whether they're experiencing chest pain. So clinical measurements that you might be able to take. And the main column of interest is this one over here called diameter narrowing. And I believe that means that's just a measure of the whether the artery has had the diameter narrowed, and that's an indication of heart disease. And so that one's harder to measure, I believe, compared to the rest of them. And that's why we might want to use these predictors to help classify this final column of whether the diameter of the arteries is narrowing or not, because we can't easily measure that. So a bit more about the data. So the first two rows are kind of confusing, but I think C means it's a continuous variable, and the D means it is I've lost it. It's a discrete variable. So basically numbers and categories. And some of the categories have the options listed up here. So there's 4 different options there: normal, left, vent, hypertrophy, STT, or abnormal. And yeah, I think that's it. So these two columns, 2 rows aren't really necessary or common, but they are in this data set. And yeah, the rest is fairly self-explanatory: ages, males, females, and so on. Okay, so that's what the data looks like, but we can also do this in orange, which I'll cover as well. So back over here, I'll click on File again, open this up. So I double click that. And you can see now these same data are being picked up by the file widget. And in this case, the type, instead of being C for continuous and D for discrete, it's N for numeric and C for categorical. But it's correctly sort of loaded this data in. You can modify this if it gets it wrong, but it usually gets it right. So it could be any 4 of these different types. So category, text, date, time. I just changed it to a date time. So I want numeric for that one. And yeah, the interesting one down here, it has this, these are all, the role here can be a feature. But the important one that comes from this data set, which is called a labeled data set, because we have the answer to the data set already. This is called the target variable. And the hypothesis is that all these feature variables here are somehow related to this target variable. And we want to build a machine learning model to prove that. So we have a labeled data set to make that proof. You can do things with unlabeled data sets where you may not, you don't have the answer. And we can talk about that too. But for now, we have a labeled data set. And generally, machine learning comes in 2 flavors: supervised and unsupervised. And basically, that means labeled or unlabeled data. All right, so I'll stop talking about our data now, but I think that's all good. Oh yeah, the roles also, you can feature, target. Meta means metadata, or skip, so you can skip the column completely. Oh, I don't want to skip that. I want to keep it as a target. Good. So close that. And now what we're going to do is do something with this data. So the first thing we might want to do, I'm going to drag a little icon over here. And it's even sort of coming up with a few suggestions of the widgets that I want to use. So in the first one, sure, let's go for a data table. And we can just look at our data the same way we were observing it in Excel. So, you don't need Excel, you don't need to open it up. Here's our target variable here and all our features over here. Good stuff. So that's nice and boring, which is good. Boring's nice. We can also add, so there's 2 ways we can kind of get more widgets on. We can either click and drag like we just did, or we can click over here and explore what our options are. So I want a scatter plot. So if I click that once, it gives me a scatter plot, and then I can do something like click and drag and connect the scatter plot. And now I can get a very quick and very, very nice visualization of the data. So it has just by default put the x-axis as the age and the y-axis as cholesterol here, 2 numeric continuous variables. And then it's colored them by our target variable, the diameter narrowing. So yeah, a good way to look at the data. We can see ones, I guess, mean that the diameter is narrowing, so they have heart disease, and zeros mean they don't. So they're the 2 labels that we have for our data. And if there's a really strong relationship between age, cholesterol, and the diameter narrowing, we'd see distinct clusters between these data sets. And sometimes that comes out really clearly, but not so much in these 2 particular variables. If I pick some others, maybe yeah, maybe let's yeah, you can explore through them and see if you can come out, see if any appear easily, but not always the case. Okay, so yeah, you can do things like change the shape of them to match certain things, the size. So similar things you can do in something like Microsoft Excel if you have the time and patience. But very nice visualizations. You can hover over each icon and get some information about the particular data point, so the entire row of data there. And yeah, there's quite a few other sort of options that you can have, and you can click down here and save the whole image out if you want. So my figure. Oh, yeah, gee. Cool. All right, and let's see what else is interesting here. Okay, so the next thing I have that might be just interesting is picking some other sort of doing some other exploratory data analysis on our data. So you can pull out the feature statistics here, and I can drag the data of the feature statistics. And if I open that up, that's a really nice, another nice just overview of our entire data set. We can see the distribution of each of the variables that we have and how it relates to this, the target variable at the moment. So zeros and ones, and where they lie. And again, if there's a really distinct relationship, you'll see sort of different populations of the two classes. Okay, and you get the means, modes, medians, and all that, and it tells you if there's any missing data as well. This is a pretty clean data set, and there's a couple of missing items in a few of them, and orange can help with that to some extent, but it does like a mostly clean data set, and we can also change this to look at different categories. Which is super neat. Okay. And we can also do things like if we want our scatter plot to we want to visualize some data from our scatter plot, we can drag another data table on and drag from scatter plot to data table, and then when we open the scatter plot, well, let me just deal with the screen real estate and the data table here. Sorry. Okay, so I've got both of them, and now if I select one, it appears in that data table widget. So I can sort of get, can I drag and select? Yeah, so I can sort of select different groups of clusters, and I can drill down into it. So you can see the beauty of how these widgets can connect together in different ways sometimes. And sometimes it's not fully intuitive that, I would connect my data to a scatter plot and then scatter plot to a data table. Sometimes you might want the data table to a scatter plot, but that comes with what you're exactly trying to do. Okay, and there's a bunch more other visualizations out of the box. You can do, I'll just do some things, like something like a heat map on here might not make sense. And yeah, we've actually got a little warning indicator of the scatter plot. I didn't notice that one, but this one has like a warning indicator. And if I click it and open it up, I get the warning down here saying categorical features are ignored. So that's not too bad. It can still deal with it. Occasionally you'll get a red icon, which is an error, and it will tell you sort of why those widgets can't fit together, and you can explore further from there. Okay, how are we doing? Any questions coming up in the chat? I'll just catch up real quick. So does Orange prefer tab set? Oh, thank you, Daria. Fantastic. And if you need to claim the data, fantastic, Daria. Thank you so much for responding. That sounds about right. I just said, I believe. Okay, so from here, if you want to start doing some machine learning, so let's start fitting a model to our data. And there's a couple ways to do that. Over here, try and be intuitive about it. I'm going to guess that we pick the model button. We're just looking at visualize button. So the model button has a whole bunch of pre-configured machine learning models that we can pick from. and also some saving and loading, and stacking some tools around the modeling. Now, I don't know what all of these are and how they work, but a few of them I'm more familiar with. So I'll pick logistic regression because we have a logistic regression problem, I suppose. So if you're completely new to some of these methods, sometimes your data has to fit the model, or the other way around, the model has to fit the data. So in our case, if we're going with the story that we have one target variable that we want to train a model to be able to predict based on all the other features, we can use something like logistic regression, which is good for classifying different different features or a series of features into whether it predicts the one or the zero, the narrowing or the not narrowing. If we were predicting something like the age of the participant, we do more like a linear regression where we're fitting a trend line to the data. Logistic regression is somewhat similar, but it kind of pushes the data into that binary classification. Okay, so this one I've just connected to nothing at the moment. It's just sitting there on its own. You can open it up, and there's actually not there's not many options in there. You can set some details here if you're familiar with the modeling, and adjust some what are called hyperparameters of the model. But the defaults are normally fine. You can also, I haven't mentioned, you can also lodge peg one. You can also name the widgets if you like. I think you can rename them here as well. Okay, so what we want to do with this logistic regression is evaluate a new model. So to do that, we're going to drag something in called test and score. I'm going to test our new model. So this one, I think, takes a little bit of watching demonstrations and looking at some examples. We drag the logistic regression to the test and score, and then we also drag the data to the test and score. And there we go. Did you see that? It happened really quickly. But if we open it up, I now have an answer to our prediction. Basically, our model, logreg1, has just been fit to our data. So it happened all pretty quickly. Most of these models are somewhat they're very efficient, and so they can run just on your local computer. The other great thing also I just point out now is that everything's running locally. So, you're not losing, your data's not leaking anywhere out to the internet. Everything's all done within your local machine. So that's nice and easy for ethics approvals if you're working on sensitive data and so on. Okay, so this is our data and our logistic regression model, and it's giving us a bunch of answers here, or metrics, and these metrics are related to how well the model has done at fitting to those ones and zeros. How well does the age and the cholesterol and the gender, how do those metrics or how do those features relate to our target column? And the first one, this is called the AUC, the area under the curve. It's given us 0.9. I can tell you now, all these numbers closer to the one means better. So one is perfect. Although if you're that high, probably something dubious is going on. And this other one, classification accuracy, F1 score, precision recall, and MCC. I might have to read the documentation for that one. But basically, we're doing pretty well. And I did mention we can read the documentation, so I'll do that right now. I can click help and get a little help icon. You can also read the help online, and you can scroll through and read about all the different options that are there. So oh, there we go. The Matthews correlation coefficient takes into account the true and false positives. So that's a new one for me. All right, so what does this mean? What can we do with this? We can explore how this model is performing in a few ways. So I'll close this, and I'm going to now use something called a confusion matrix. to see how our model's performing. And if I drag this across, maybe this, so this is something called a confusion matrix, and it's scoring how many answers the model got right, how many it got wrong, but also how many, in what categories it got right and wrong. So there's two categories, 0 and 1, for the actual data, and 0 and 1 for the predicted data. And it's seeing which ones it predicted right in the 0 category, which ones it predicted right in the 1 category, which ones it predicted wrong in the 1 category, and which ones it predicted right in the 0 category. Did I say that? In fact, I think this is the best way to explain this. Here's one I prepared earlier. So yeah, this diagram, I think, it explains it very well. True positives. This lady is being told you're pregnant, and she appears pregnant, so that is a true positive. A false positive, this man is saying you're pregnant, but it's likely a false positive. A true negative, where he's being told he's not pregnant, and yes, he's clearly not pregnant, and also a false negative, when she's being told she is pregnant, but she is in fact pregnant. So that's a great way to think about true positives, true negatives, false positives, and false negatives. I'll just point out the predicted values on the y-axis here, and the actual values on the x, compared to what we were looking at. All right, so yeah, that's one way to explore your data. There's what else have we got here? The ROC, the receiver operator curve, very common way to see how your model is performing. Basically, the more this looks like a big corner of a square, the better. So this is, and this is that dashed line represents average performance. And you can think of this curve as as the model is predicting yes or no, or 1 and 0, it draws like a threshold for the decision at 50%. However, in the receiver operating curve, it then moves that threshold up to be 60%, 70%, 80%, 90%. So what happens if all the models were predicting 1, but they were only taking the ones that were 90% sure that they were correct? Then you'd be sort of up in this region here. So hopefully I explained that okay. But basically, yeah, you want this shape to look like something like that to know that your model is performing well across the spectrum of that thresholding. Okay, and whilst it's sitting there, we've got logistic regression. We can throw in a bunch of other models too. So let's compare we'll put a random forest in, we can put a neural network in. So let's just drag those on. Look, it's counting 70, 89%. And there's another one, that one was really quick. So a neural network, they're the same sort of tools that are used in sort of deep learning AI, like ChatGPT, that uses neural networks. Random forest, that's it's a very different approach again to machine learning, but they're all doing the same thing. They're trying to find the correlation between the target and the features. And now if I click on this, I can see I have more values in here. So it's automatically found the results for testing. And if I can look at my receiver operating curve, I've now got 3 of them. So it's a fun way to sort of compare how models are performing. And again, if you're new to machine learning and you don't know what model to pick, like, it's great because you can just throw every model at it. Some of them don't make sense, so I'll demo that. But also, yeah, some data works best with some models, and there's reasons why you might pick one model over another. But it's often the case that you throw everything at it, depending on what you're trying to show. And yeah, see which one performs the best. Okay, I can do something like a linear regression. Let's see what happens here. Did it work? Oh no, look at this. I've got some errors here. So it says down here the linear not working. I'll read it. Okay, it's not showing on my screen, but it failed because it can't work with this type of data. That's the gist of it. And so that one just won't work. So I can remove that one if I like, or maybe I'll keep it there. Yeah. Okay, so now we've built this full model. We want to do something with it. We want to, we've proved to maybe the reviewers of a paper that yes, this prediction is true. Like look at our ROC analysis. So there is definitely a real genuine relationship between our features and our target. That's something new that no one's ever seen before. But the next natural step, and especially if you're in like commercial settings, is you want to deploy that model in maybe like a clinical environment and say, let's use these to predict values where we don't have the labels for. We may have taken these numbers for a whole bunch of patients, but we don't know whether they have heart disease or not. So let's try and predict it before we have to do something invasive to measure that. Uh, all right, and so the way to do that is first we save this model out. So I'm going to save model, bring this here, and I will drag this to my linear regression. And is it going to work? No, okay, you see the dashed line? It's still waiting for something else. And that is because I also need to drag my data. So that's like a unique line. So the data goes to the logistic regression, goes to the save model. All right. And if I click save, what happens? Oh yeah, it comes up and says, how would you like to save this model? So let's call this logistic regression model production. Right. Save. And that's great. So it has now saved. Let me open up a new folder. So in my file here, it has saved this model here, logistic regression underscore model production that we just made. And it has this weird extension, PKCLS. I think this is native to Orange. It's somewhat related to a file called a pickle file, which is used in Python to store data efficiently. And it can be read by common Python libraries. So if you wanted to then use this in some other format, I think you can do that. But you can also use Orange within Python to deploy this model somewhere. However, you can also do that directly in Orange. So you don't need to know that. It's just a file on your computer. It's probably all you need to know. And so we can, on the same workspace, we can do something like this. We can go and say, hey, give me a prediction. So got a prediction here. And if I click on that, it actually does down here, it actually says what we need to bring in. So it says no data on input, and then yeah, no data on output. You can click the help again, and it'll tell us which inputs we need. So in this case, we need an input data set and predictors to be used on the data. Okay, very good. So okay, so for that, I need to, let me close that. Okay, I want to do two things. Firstly, I'm going to load a model, which will be the model we just saved. Sorry, I'm going too fast here. Yeah, so that's the model we just saved. I'm loading that in. It's now loaded. That's it. As I mentioned earlier, Orange, everything happens immediately. So there's no sort of buttons to click apply usually. And I connect that. So that loads the model, but so I have this model here. It's pre-trained. It knows all these things about how to fit certain features that we have named to this target variable. But there's nothing to show yet because I need one more piece of information, and that is new data. So I need some new data, which you go out and you measure these things. Maybe you generate a bunch of data and you want to explore the full range of what's possible. And I can go and so I need to load in one more piece of data. And this is actually one I prepared earlier. It's very similar to what we've seen, except it says three rows of data, and it's missing the last column. So it's missing that predicted value, the target variable. That's because we don't know it yet. We haven't measured it in this data. So we want our model to predict that. So I'm going to come and pick another file to load and open that up. And I'll need to explore to my data, which is down here. Masterclass Heart Disease Predict. So it's a CSV file this time. I saved it as, again, it's done a pretty good job. For some reason, it suggests that the last value is a text value. That's not the case. It's categorical. So I just fix that up. Okay, this is one exception where there's an apply button. And now if I do this, I get some predictions. Aha, look at this. So I have my data here, and it's predicted 0 for the first one, 1 for the second one, and 1 for the next one. And in real case, I wouldn't know whether that was accurate or not because I don't have, unless you went and made this measurement somewhere else. But in this case, like you have to trust that the model has been trained successfully. Okay, and with these predictions, you can also do things like you can pull out the feature statistics like we saw before, and you can have a look at what our model on. So this is the prediction for those couple of data points. So we can explore it just like we did earlier for the raw data set. But this one has our predictions coloring the features instead. Okay, and we can pull a data table in as well and have a look at that. And so there's our three. The Lodge Reg one, that's the model outcome. And I think that's about it. So yeah, maybe I'll stop there. I've given a general overview. I'll just show you two more things. I'm just in the help menu, which is off the screen I'm sharing. There is a button called example workflows, and you can get a bunch of workflows. You can open them up and explore how to do sort of different types of data exploration and machine learning. So that's a great starting point. It gives you sort of ideas for how you can make connections between things. Some are more complicated than others. Component analysis is nice. So this is a technique to kind of combine your data into smaller subsets. And you can just hit open and it's ready to go. You can load your data in and go from there. Make these comments as well on here. So it's a lot of fun. All right, so that's I think everything I'll say. If there's any questions, I'm just browsing through the chat. Can this be used for longitudinal data analysis? Is anyone from SIH? Does anyone know that answer? I've never done that. Only more for this sort of EDA and machine learning type analysis. So I'm not sure about that. Just any other questions in chat? Now I will just I'll finish here with this. Sorry, with if everyone has a moment to fill in the short survey around the around this workshop, and I'll post all these links as well because these might be useful for you. If you want to grab those, I'll put this recording up on YouTube and share it with all the participants as well. And is there a model workflow for repeated measures data? That is also a good question. I don't know the answer to that one either. I'm guessing there is. Well, let's do it now. Repeated measures, orange. Is there anything orange data mining? Mystery of test and score. Yes. Frequent item sets. Maybe that's the equivalent. Oh. Hello, is someone talking? I just realized my.
Yeah, sorry, Nate. I was trying to chime in. Hi, everyone. I'm Daria, also from SIH. So I think the answers to both time series, so longitudinal data analysis, time series, and sort of repeated measures is probably not. So this is orange data mining is really powerful for data exploration, quick data visualization. So as Nate showed, like he did a quick scatter plot, but there's also, if you go to visualize, there's a bunch of like make me a violin plot, make me a Venn diagram, make me a flow plot. And violin plot, you can also do one when you load your data in. You can say that the class that you're trying to predict is, let's say, the different, you have patients that are from 5 different categories. You can say that that's what you're trying to predict, and then it's going to give you this beautiful plot specifically for the 5 features you're interested in. You don't have to do any machine learning with it, although that's what it's optimized for. You should just basically do this to, create a beautiful plot of what the distribution of your variable looks like. In terms of sort of the complex statistical design, it's not a statistical program. It is a machine learning program. So it is very much for prediction and for sort of that base data science. It also does allow you to do a certain amount of data cleaning, and that's where the transform panels are useful. But I think for both repeated measures and for longitudinal data, you really want to be using classical statistical approaches or sort of dedicated time series models, depending on what your longitudinal data actually looks like. And that's not really something you're using in orange. So you can see that on the left, it has sort of yes, some stuff for survival analysis, probably the most statistical it can be. There is something that says widgets for time series, although they weren't popping up for me in my version of Orange. Can you go to time series in your actual, on the left, Nate, in the documentation?
Yes. Okay. Sorry, this is one thing I meant to mention. There is you. I brushed over the available widgets. So you have a bunch of add-on widgets that you can install. So the default ones are fairly robust, but then if you want to do things, here we go, survival analysis. You can install that time series and install that, and you can download those, and then hopefully they'll be populated there, and they'll give you a bunch more extra widgets. I don't know how long that takes, but yeah, so you can also browse. Yeah, we're in the widget catalog over here. So I go back to the front page, I think. Yeah, you can get the top ones are the default ones, and then you get down here and you start to get to the specific ones that people have contributed. So text mining, there's your survival analysis, bioinformatics, and so on. You can do images as well.
And you have a look at what it says for time series.
Time series.
Yeah.
Anything in particular?
So yeah, you can do it. So depending on what's appropriate, you can start to play around with at least a basic ARIMA model, which is sort of step 0 for playing around with some, at least visualizing and not understanding some. Again, depends on what your longitudinal data is, but yes. But again, it's not a statistical program. It's very much more about data exploration, visualization, cleaning, and then its end goal is usually prediction in the format of machine learning. You don't have to do prediction or use it to do that prediction, but that is what it's designed for. So that's sort of what it's optimized for. Again, there are other tools that may be better for no code stats if you're trying to do classic statistical modeling.
Yeah, thanks, Daria. All right, any other questions? All right, well, we might wrap up then. So thanks again, everyone, for joining, and hopefully we'll see you again at future masterclasses and training workshops. So thanks very much and good day.
Thanks.